Now we come to the structure of a linear programming problem. By structure we mean what are the components of a linear programming problem. So there are three basic components of any linear programming problem. Now what are those three components? The first one is decision variables. Now these decision variables are denoted by x1, x2, x3, so on and so forth, xn. As we all know, these x1, x2, x3, etc., they are used for representing variables. By variables we mean they can take different values. And one more important thing associated with these variables is that they are non-negative in nature. They are non-negative in nature, which means x1 is greater than equal to 0, x2 is greater than equal to 0, so on and so forth, xn greater than equal to 0. Now what is the significance of this? In any linear programming problem, these variables, that is x1, x2, x3, so on and so forth, they actually represent resources. Resources such as man, machine, money, so on and so forth. And you know, resources are never negative. That is why it is clearly written over here that these variables are non-negative. It means at most they will take the value 0 but not below that. They can never be negative. So x1 greater than equal to 0, x2 greater than equal to 0, so on and so forth. This is something very important. So these decision variables are x1, x2, so on and so forth, and they are non-negative in nature. It means they cannot take any negative value. Then the second important component is the objective function. Now this objective function in a linear programming problem is expressed in terms of decision variables, and our objective is to optimize the given function. Now by optimization we mean either we have to maximize it or we have to minimize it, depending upon the nature of the problem. For example, if it is a problem related with profit, of course our objective will be to maximize the profit. On the other hand, if the problem relates to cost, then our objective will be to minimize the cost. And in general mathematical form, the objective function is represented as like this: maximize z is equal to c1 x1 plus c2 x2 plus so on and so forth cn xn. So this is a case of maximization. It can be a case of minimization also. Then we will write minimize z is equal to c1 x1 plus c2 x2 plus so on and so forth up to cn xn. Now here in this objective function we must understand what is this z. This z is actually a measure of performance, wherein we can measure the performance. Now that z can be profit, it can be cost, it can be time or whatever. And these x1, x2, x3, xn, we already know these are all decision variables. And these c1, c2, cn, etc. are the parameters that represent the contribution of unit of the respective variable x1, x2, xn. So this objective function is very important.